Okay. All right, cool. So I'm recording. So I guess we can get started with like anything that somebody's having any issues with that we could work on together. Maybe look at like some homework problems or something like that. If somebody wants to share the screen.
Hey, can I ask a question real quick that I'm kind of confused about?
Yeah.
When naming the compounds,
Mm.
where do you like if there's a bromine attached to the structure? Where in the name would you put the bromo?
Okay. That is a good question because so basically it goes in alphabetical order. So if say you have a bromine on 6 and a chloro on 1, the bromo would go first, although it's not numerically first. So it'd be 6 bromo, 1 chloro, and then whatever you have after that.
Okay.
Right.
And what about if you had a methyl group as well? Would methyl group go before the bromo or after?
Like
Like it would be
say like
bromo.
if it's like 2 methyl or something like that.
Yeah, like say you got like 3 bromo, 4 chlorine, 2 methyl.
3 bromo, 4 chlorine, 2 methyl. So you're still gonna go in alphabetical order. So methyl goes after chloro. So you said 3 bromo, 4 chloro, and then whatever number you said, methyl.
Yeah. Okay.
Yeah. I think he said alphabetical trumps everything. Because he kind of confused me how he had the numbers. Like, okay, so for one of them, it was just ethyl nonane, but they had 3 branches off of, no, it was nonane, and then they had 3 branches pulling off that was an ethyl from one spot. So he did 2,6,7 trimethylnonane. So from there, I assumed that we would be doing the numerical for all of them, but really the alphabetical, whenever you have different like bromos or chloros, alphabetical goes first. Did that make sense what I'm trying to say? Because
Yeah.
in my head it made sense, but it didn't make sense.
Alphabetical over numerical.
Yeah, okay. All right. Now that we got that clear, let me see. I haven't opened the homework, y'all. I'm gonna be honest. I did the worksheet where I did worksheet 4. So I'm gonna see if I can open up my homework real
I'm the opposite.
Yeah, I did some of the worksheet. I did most of the homework, some of the worksheets.
Okay.
I didn't even look at the worksheet.
The worksheet is just naming from the bond line and then the reverse, naming from the actual name, the molecule name.
All right, I'm gonna need this.
I'm gonna pull it up and then we can work a little bit on the worksheet. We could do a couple problems from the homework. Whatever, keep it chill. Let me see. So what's you guys' majors? Or like are y'all like STEM?
Yeah.
I'm biological sciences, pre-dental.
That's what's up.
Mm-hmm. Same bio.
I'm Chem, pre-farm. So
Oh yeah,
Oh,
we need you in
yeah,
here.
I'm in it. I took my Gen Chems last year, so now it's OChem this year, and I am a little frazzled.
you
A
got
lot to
this.
remember. It's a
You
lot
got
to remember
this.
for sure. Let me see.
I'm gonna say pharmacy. I know you gotta remember all the chemical compounds of like all the most common drugs, or like it's like 200. It's something like that.
Yeah, it's gonna be a lot.
You got this. You got this.
I hope so.
Go get that pharmacy degree, girl.
We all trying to get this degree, man. That's why I said I ain't got time to fail. Not for no chemistry.
No way.
78149. I'm gonna do what I got to do.
I'm not traditional as it is.
Sorry, y'all. My stuff, my Wiley is so jacked up. I have to go from the flyer and re-put in the thing and put my information in, like, to get to the page. It's so weird, but
Really?
yeah, like it doesn't work straight off of the login. Like I have to go from the flyer.
Never heard that.
Yeah, I told him that in the beginning. He was like, "Oh well, figure it out." I'm like, "Okay, if you say so." Okay, I have it opened. Let's see. All right, cool. So you guys want to start with Wiley Plus homework or worksheet?
Let's do the homework.
All right, cool. All right, so let me see if I can share. I wonder if our problems are the same problems or is it?
It should be.
Okay. Let me share the screen. Y'all see that?
Mm-hmm.
Okay. Is it the same problems?
Yep.
Is
All right,
that
cool.
number one? Yeah.
All right. All the following are representations of cis 1,2-dimethyl cyclohexane except. Okay.
All right. So I did this problem, and I kind of just, I'm not gonna lie, I kind of just did a lucky guess because I looked at the second one and I noticed the second and the fourth one, and I noticed that the fourth one was a little different. But I saw that they had the methyl group pointing downwards for the second one, and then it was pointing like a J. I want to say not parallel. I don't know, but it was pointing outwards, and I was like, that don't look right. So it was lucky guess, but I don't know the correct term.
Yeah, I answered it. I got the correct answer. I just don't know how to like tell if it's the first one or the last one because both of the methyls are on the same side.
Yeah, same.
Right. Okay. Okay, so let me from what I'm seeing, you're gonna know that cis with cis and trans, like cis means on the same side, trans means like on the different side. I don't know why I'm doing this arm thing, but so looking at that, I know that the first one is cis, both of them are on the same side. I know that the fourth one is on the same side. And this looks like it's on the same side. So this one wouldn't be the answer? B?
Yeah, that one's not the answer.
Okay.
Oh, yeah.
So everybody understands how
no.
that works?
Yeah.
No, the correct answer is the last one.
Yeah, it's the last one.
Wait a minute. Okay, hold up.
I just realized the question says except.
Yeah, except.
Oh. Wait.
Yeah, what?
Well, then that's what my little explanation that I went through making me sound kind of smart didn't matter anyways, because that's not what I was thinking. I was like, okay, yeah, because it's on the same side, so this one cannot be it. That's it. Okay, I don't understand why Let me write that down. I'm gonna ask. I need some help. Need some help.
It made sense in my head because I thought you were eliminating that one.
Yeah,
Being that it's not
the
two.
second one. That's the one
Yes.
I was talking about. Shit. I'm sitting here like, okay, let's get it. Dead wrong.
Hold on, let me turn this up.
That one in Piazza. Y'all help me out. Opal sister. Oh. All right, let me see. Mm-mm. Mm-mm.
That exact question has a slide in the PowerPoints. I'm looking at it right now, trying to figure out the answer.
Okay. Yeah, because that, with the reasoning, you think B was right.
Yeah, it
Like,
says
it was accept.
yeah, this slide has the same exact example. Oh,
You want me
Is
to
B a
unshare my screen so you can see it?
I'm doing it on my iPad, but I think I think what it's going for is the energy because the chair would be more stable.
Okay.
Because yeah, it says right here each compound exists as two equilibrium chairs, sending more time into more stable conformation, and it shows the different examples. Like right here, like it shows all of them, but it's saying the lowest energy one is the best one. So I'm guessing we have to go for the lowest energy with the like angle torsions, if that makes sense.
Okay. So that one isn't, it wouldn't represent cis 1,2 dimethylcyclohexane because of the energy. Okay. I'm trying to grasp it. I'll get it eventually.
It's if you look on the slides, it's like the last two or three slides.
Okay, let me see if I can pull it up.
We probably don't get it because we didn't finish video 3.
Let's see.
It's something with the equatorial and the axial positions as well as the energies from what I'm getting.
Oh, I see it. All right, let me see. New share screen. Okay. Is this one right?
Yeah.
Okay, for each compound exists as two equilibrating chairs, spending more time in the more stable chair formation. Okay. Ooh, shit. Sorry, y'all. Let me go back. Okay. This is the lowest energy conformation for the cis isomer. This is the lowest energy conformation for the trans isomer. Okay. I'm not understanding, but I'm not truly understanding what they're trying to tell me, but
I feel like I kind of have an idea of where it's going. I just don't have the complete idea.
okay.
Yeah, I don't understand. What the hell?
Okay. So I'll just know that that one right there, if it's like this, then it means cis. At least it's kind of going in the same direction. I can see what you're talking about. But versus that other one where it was like parallel, I was obviously going to choose the one that was parallel because it's on the same side. That was really tricky. I don't know why he put that there, but I can understand how trans was completely like going opposite ways. I can see it now a little bit. But yeah,
Can you go back to the question?
yeah, sure. Where am I? Hold up. There's so much shit on the host thing that I'm trying to move this shit out of the way. Okay. All right, and then share.
Um,
Here we go.
this is
It's on there. Y'all see it?
yeah. What I'm okay. So what I'm thinking it is because the you're gonna have like the electron clouds around that methyl group, and the last answer they're going to be too close. They're going to like overlap, creating negative energy, like a negative energy torsion strain.
Okay.
So that's the only thing I can think of that's different about that one. So like because that energy, that negative energy, the strain, it's gonna not be a stable representation. So maybe that one just does not exist in nature because of that. That's the only thing I'm getting. I can think.
Right. Okay.
I don't know.
I can see, but I can see where you're coming from, Bryce. I just in my head looking at it, it's tricky. You have to know what it looks like beforehand. You can't just come off the back because I would have picked D on the test.
Yeah,
To be honest.
that was my first choice as well.
Yeah,
Um,
I picked D, but my logic was probably had nothing to do with what the real logic is.
Right. Like
Because I
I'll pick
know
it, but I
that,
don't know the understanding behind it, and that's so bad.
right. I knew it wasn't the one that you were initially ruled out, and I didn't pick the Newman structure because I thought that it had to be in ring structure, being that the name contains cyclohexane. And I knew that when the two methyl groups are in the equatorial position, that they mean they're pointing up. So that's why I picked that one.
Okay. Right. No. We are learning. We are learning, guys. It is okay. We are learning. Okay, let's do the next one. Which of the following is expected to have the largest heat of combustion? Okay.
Yeah, I had no idea on that.
It's like boiling point, all that shit. It takes a lot to remember. Okay. Let's go to the slide where it talks about heat of combustion. My good sir.
I feel like he's a really crappy teacher.
He glosses over like everything like it's nothing.
Like he just reads exact from the slide.
See.
I mean, compared to the other organic chem teacher, he is magnificent. So
Really?
Who's the other
really,
one?
I took
Jurassic.
I took juristic, but at least he gives examples and works it with you. But like this one, he just reads from the slide, and I feel like the slides are so different from the homework and the test.
Yeah, I mean, but at least he works with you like during rec and in
I
our
know that
lectures.
this problem has something to do with like the strain.
Okay. I see on slide 39 they're talking about heat of combustion in a it's like in a chart. I'm gonna share it. So like it's in like a heat of combustion, like showing cyclos and then the number of CH groups compared to the heat of combustion. So I think that might help us, being that, yeah, all of these have a cyclo something. Like this is cyclo, the triangles are opposite. Yeah, cyclopropane, then there's cyclohexane, and then cyclobutane, that square.
Yeah, it's saying that any cyclopropane has the highest. Like as you add carbons, the heat of combustion goes up.
Cyclohexane, you said?
Yeah, like
Right.
as you add more carbons, the more heat of combustion, the higher heat of combustion will be.
Okay, so let's take a look back at the thing. Then this should be good then. Okay, let's see.
It's one of the triangles.
One of the triangles or the cyclohexane?
Wait, so
The answer is the one with the two wedges.
Oh, okay, because this is another C. 1, 2.
Well, why is it the one with the two wedges and not the one with the dash?
I don't know. I just got that one right.
Let me see. 1, 2, 3, 4, 5. The one with the dark triangle and the dotted is trans. The one with that one is cis, with both dark triangles is cis. There's nothing on the cyclohentane, so I wouldn't expect that one to have the highest combustion. I'm gonna cut that one out.
Because it pulls up, that's exactly right. Because the ones with the dashes, think about both of the methyl groups coming out of the paper, like they're coming towards you, so they are cis, which creates a dipole moment.
Right. So from what I know with what is it called? Is it like London dispersion?
Yeah.
It was like from the first test. Like it goes in order from like highest melting point and boiling point, where like hydrogen bonding, stuff like that, dipole forces and stuff is at the top. They have
I know hydrogen bonding is the strongest.
Right. Okay.
But
so,
I think it's that one because it creates a dipole moment.
Okay. Cool. So that's the reasoning, because we have the answer. It's just we need to understand the reasoning for the test. Cool. So we are saying as a collective that is the answer because it is a cis molecule, meaning that it comes out creating a larger dipole moment than the other choices.
Well, the other one, because it's trans, the dipole moment will cancel out. Like,
right, because it's going opposite ways.
Yeah, so it won't have a dipole moment.
Cool themes. Look at us. I like it. I like it a lot. Okay, which of the following is a constitutional isomer of heptane? All right, so.
It's not. It's going to be the second one.
Yeah,
Yeah,
that's right.
it's B.
Okay. Do we know why?
It's
I don't
not
really
a
know why
cyclo.
looking at it.
Well, it says a heptane, so you know it's not a cyclo. It's the ending is A and E, which means it's all single bonds. So that takes out this third one. The first one has an extra carbon. 3, 4, 5, 6, 7, 8, 9. Yeah, it has 8 carbons.
Cool. 1, 2, 3, 4, 5, 6. Okay, yeah. Got it. Is there a problem that y'all want to skip because like I didn't do the homework. So
I didn't know
like,
how
cause have y'all
to
done these already?
where when they ask what is the structure of 3-ethyl 3-methylpentane and they want you to draw it. I skipped those.
That's what I was about to say. I did the same.
Yeah.
Y'all, do you know the question number?
It's 020.
Okay,
I got that one. I answered that one.
let me see. Oh, you would have to draw it. Okay, 3-ethyl 3-methylpentane. Let's see. I think I can do this, but also the whole drawing stuff on here is so shitty. It's like,
Yeah.
it'll fuck you up. You can know what you're doing. Like, if I'm drawing it on paper, I got it. But putting it in here,
Like from the name, I know it's 5. The parent chain has 5 carbons, right?
yeah, that's
Yeah.
the little the cycle, not the cycle. Ugh, what am I trying to say? The pentane
So
has
I
5 carbons. Yes.
drew
Depends.
it and I have the answer. I just gotta figure out how I got the answer again.
Wait. Okay, let me do this. 1, 3, 5. Okay, so I have 5 down. And then at 3, there's an ethyl and a methyl. So get my thing. No, that's not 3. 1, 2, 3. There's a methyl. No, an ethyl.
So right.
That's
what
a
I had.
methyl. Okay, wait. What is that? Okay. So I got the ethyl part. No, I don't.
That part's correct.
Okay, cool.
Now towards the right, that is wrong, and I just don't remember how I got this answer though.
Toward like this
Right,
stuff
so
here.
yeah, delete those 2 lines.
Okay.
And then from the 3rd carbon, you're gonna put a methyl group kind of going down. It's gonna go at a down angle.
Like
Go up.
1,
Wait.
2.
Okay.
I think
On the
there's
3rd
more than one
carbon.
way.
Okay, what I did is like on that line you just put another group for the ethyl to make it ethyl. And then I have a methyl group attached to the 3rd carbon as well.
Like that?
Yes.
No. Oh, okay. I got it right. I have it right too, and I didn't draw it like that.
Yeah, this looks like Transformer or something.
The way you were drawing it at first would have been correct too. Like the M shape with the ethyl at the bottom and then one line coming from the top. That would have been correct also.
All right, let me draw yours also on the side too, just so we can see it side by side. So I have my
Right. And you draw your ethyl at the bottom.
All right, cool. Wait, sorry. All right, then I do my boom, boom, and then.
Right. And just one coming straight from the top.
Oh, straight from the top. Okay.
Yeah, mine is just like a rotated version.
There we go. So oh yeah, I can see where both it works. It's just this is like, it's like.
Yeah, that one confuses me for some reason.
Yeah, it's hard to look at, but yeah, his is just like it's like on its side.
Yeah, it was like rotated like 90 degrees. I could see how I had trouble with it now though.
Right.
I had trouble with the attaching the bond angles on the 3rd carbon.
This is good though. I like this.
Yeah.
Okay,
I'm
cool.
glad you had a different way. Because
Yeah.
I would have been thinking it was wrong just because it was different.
All right, so let's submit. Cool beans.
Now I couldn't do this on my own.
It's better when you have people like to consult with. I know
Confirm
that.
your confidence, I guess.
Right. Okay, cyclopentane. Let me get my little ring together. Put the ring on. Cool. And then we have a methyl at 3 and a cyclopropyl at 1. So let me, do I do that, y'all?
Yeah.
Okay, cool. And then I put my propyl.
You're gonna have to make it with the single bonds.
God darn it. And then, that's how you make it?
It
Yo,
took
Wait,
me
what
like
we
15
did?
minutes
What we
to figure
did?
it out.
So I just made the cyclopropyl at
Wait,
1.
You
Wait,
got
what?
that. Now you just have to add the methyl group on 3.
Right. So 1, 2, 3. Okay, cool. So
Wait,
that's,
what the hell just happened?
so this
I
is what we
know.
did. First thing we did was put the pentane ring down. That's easy.
Right.
Then for 1, we had to add a cyclopropyl. So I added my little bond connecting it, and I made a triangle with the single bonds because they don't have the little propyl at the bottom like how they do for pentane and hexane. Then I added my methyl group at 3, how it says 3 methyl. So I added that at the 3. Does that make sense?
Run that back one more time.
Like,
All right,
how'd
cool,
you
cool,
get?
cool. I read it back. So first thing I did was I looked at the cyclopentane because that's our base. So I
Right.
went and added our little pentane from these little things at the bottom. That's pentane. Then I looked at the front one. We have a cyclopropyl at 1, and we have a 3-methyl at 3. So I took the single bond, added it, and then I connected 3 of them together to make a propyl.
Okay.
Like, let me, I'll just
So
do it
the
again.
triangle, the triangle is the cyclopropyl part.
Yeah, that's
Yes.
a cyclopropyl. It's off of the 1. So I took the single bond like this, and then I did bloop, bloop, and bloop. Then I took the single bond to do the methyl at 3.
Okay.
Cool?
Okay.
All right, my
Yeah.
triangle didn't come out that cute, but thank
So
you.
if I would have numbered my triangle the other way, that would have been wrong. Like, say if I would have did 1, 2, 3, like counterclockwise.
No, I don't think so.
No, it's a
You could have did it like this.
which yeah
Yeah.
your triangle can be on whichever point as long as your methyl group is gonna be like 2 carbons away.
Okay.
Right. You could have, well, don't quote me on this, but I think you could have did like the cyclo starting 1 right here, and then 2, 3 did your methyl right here. I know it's kind of confusing how I did, but
Yeah, that would just be an isomer.
right. And then you could have did that. Let me delete this. You could have did that too.
Okay.
Yep. Oh wait, why am I deleting all this? Shit. Okay, so submit. That do be the correct answer. Let's see what we got next. Of the following isomers of C9H20, which is the most stable? Okay, so we have nonane, 3-methyl-octane, 2,2-methyl dimethylheptane, 2,2,3,4 tetramethylpentane.
So
Okay.
for that one, the more substituents you're gonna have, the more stable it's going to be.
Yeah. The last one is correct.
Okay, cool. So when it's by itself, it doesn't have like enough to, well, I don't know, I don't want to say stabilize, but yeah, like stabilize it.
I guess I'm thinking it's like easily broken or something. I don't know.
Okay. Got it. So the more substituents, let me write that down. More substituents, more stable.
Yeah.
Cool. So that one will be the answer. Got it. Noted. I'm writing it down in the mental brain right now as we speak. Okay. Cool. Let's see. Next one. Choose the correct Newman projection of the following compound as viewed down the indicated bond in the correct. No, why? What? In the confirmation shown. That shouldn't have been as hard as it was. Okay. Let me see. So I have my CL at the top.
CL is going to the left.
Where?
Like if you're looking at the, I don't know, I studied this part, so if you're
Okay,
looking at the
No, by
carbon,
all means, because I don't know what I'm doing.
like
So-
you have, it's so hard to verbalize because it's like an imagination thing.
Right.
But
Mm-hmm.
if you're looking at the carbon, the way the arrow is pointing, like if you imagine standing in front of it, it's like a cheerleader with their hands. I picture it like a cheerleader with their hands, like one to the left, one to the right. So like CL is actually to the left. It's so hard to explain. I don't know, but the correct answer is B.
Trust me.
Look at
Trust
B.
me,
That's the correct answer.
Okay, I can try to attempt it. Okay, so I know if it's on the circle, then it's in the back.
Right.
So if okay, I see what you're talking
Okay,
about.
Oh,
I
okay. And the
If
dark
it's
one is
bent-
like pushing forward, right?
Right. If
Right.
they're on the single bonds, then it's to the front.
Okay.
And you
Yeah,
see
so
how
I'm
like
getting what you're saying.
So
Yeah.
the arrow is showing you how you're supposed to visualize it. So from that point, the chloride is gonna be upwards. Well, somewhere in the up, like area,
Right.
but it's gonna be on that
Like
on those
that.
single bonds. Yeah.
Okay. Yeah.
Yeah. And then so
Yeah.
the bromide has to be towards the back on the circle towards towards the left.
Like if you look at the picture, you could kind of tell that bromide is on the opposite side from the chlorine. If you could look at it, I'm not sure, but
Like, yeah. So, okay, I understand what you're talking about with if it's pushing forward, then it's going to be, okay. Let me think what I'm trying to say.
So what I had to do would help me understand the Newman projects really well is I had to go and purchase like a kit on Amazon for like $14 to where I could it has the little balls and the lines to where I can assemble, like I could physically make the model so I can see it better.
yeah,
Right.
he did recommend that last
He
class.
did.
Okay. I'm going to have to see.
But all I know is when it's bent like that, the other line connected to the chlorine, when it's bent down on a Newman project, that means that it's straight. It's just going to be a line down. If you look at B, it corresponds with B.
Mm-hmm.
Okay. All right. So the answer is B.
Yeah.
Yeah. I think what also helps me like imagine is remembering that he said that the bonds never stop moving. So towards the back, I kind of imagine it like rotating in a circle towards the back, and the front stays still, and that kind of helps me imagine the Newman projection.
I'm not gonna lie, what helped me understand what's going back in the text. They have a really good description and way of describing it.
Okay.
Okay.
It's on
Yeah.
the Wiley.
Yeah, on the Wiley
Okay.
text, that section of the text, they have a really good description.
Got it. So just to clarify, the dotted raised is in the back. So that's why it's on the circle.
No.
No, the dotted.
Okay.
Like
So
the dotted bromine?
if you're looking at the carbon that the arrow's pointing to, that's going to be your front carbon. So that's going to be the carbon, like that's going to be where the I don't know how to explain this, like just through
That's gonna be
It's
where
hard to explain.
that's gonna be
the
where
circle.
your eyesight, like that's gonna be your perspective of imagining a carbon.
Yeah, so
Right.
like
Okay.
you're looking at that carbon, it's going to be the center. Like the very center is going to be the first carbon. So the lines attached to the center carbon is what's attached to the first carbon. And then the circle behind it is going to be the second carbon. So like when you just see the little line sticking out of the circle, that's not inside of the circle. The line sticking out go to the second carbon.
Oh, okay. Okay, I'm understanding.
Yeah.
So that carbon is connected to the chlorine and it's
Mhm.
connected to an H and another
Mhm.
H.
Right. So looking at
Okay.
the bond line structure, you're looking at it from the side, but if you look at the Newman projector, they're showing you how you would see it if you was looking at it from the front.
Right. Okay. Okay. Yeah. So cool. The chlorine, that's making sense. And then in the back, okay. That makes better sense now that I'm understanding, looking at it from that point.
Yeah.
When I'm
Definitely go
looking at
look
it
at
right
that
here,
part
it
in
just looked like a
class.
circle. So I'm like, okay. But okay. Got it. I mean, I'm gonna write down Newman projections because I can practice that. Okay, cool. Let's do that. Let's see if we got for the next one. I might jump after this one to like towards
Yeah, I
the
got
bottom.
it. Those ones.
Yeah. Okay, select the Newman projection of the following compound as viewed down in the indicated. Okay, cool. So looking at it, the Cl, and then this is on the, this is kind of like the same one we just did.
Right. So
Okay,
CL
cool.
is on a bent, so that means that it goes straight down on a Newman. That's how I
Mm-hmm.
look at it. And so you can automatically use process of elimination just from that.
Right. So then it'd be this one right here.
Yes, one.
All right, cool. Okay. I'm liking it.
We
y'all.
doing it. We doing it.
Okay. I like.
Hey, I'm about to have to dip out though.
Okay. Let's
Yeah,
skip.
I gotta start on my report.
Right. Let's skip. Let's do like this one. And let's do that. And then we can log off. Let's see. Which of the following illustrates an equatorial OH? Equatorial means,
That means it comes off of the structure.
oh, okay. Like, so
Wait,
like
what question y'all on? 85.
85.
Mm.
Like pushing forward like the dark one, or pushing back like this one?
I'm trying to find the question. Did you scroll down some?
Yeah, I kind of like skipped towards
Oh,
the
you at the
end.
bottom. Oh, okay. Okay. All right, I see. So which of the following illustrates an equatorial OH? So we know it's not 2 because that's axial. I'm trying to see how I got the answer. I got the answer. It's 1, but I don't know how I distinguished that one from number 3 and number 4.
I just realized why when I said equatorial and I was like this, that's not the equator. The equator is this. Oh no! Y'all send some help immediately. Send help. Okay. I can see why it's 1
So
though.
it's 1 because those are just wedges showing you that it's either coming from the up or the top, but it doesn't show you like a aligned. So I
Right.
just
This
did
one's
one.
pushing off the side.
Yeah.
So I can understand that one. Okay, cool. Cool beans. All right. Well, does anybody like have any questions before we like sign off or whatever? Anything that was like perplexing them? I did the worksheet. So if like you have any questions, you could like send it into the Piazza or
Yeah.
whatever.
Because the hardest questions we skipped over. Like the ones I had went through the homework and did the ones that I knew, and I skipped the ones that I didn't know. Because they have questions on here that ask stuff about like TERT.
I
I
do
don't even
know I
know.
do know about TERT and stuff. So if you have a question about TERT, I know
Okay.
second TERT and ISO. I went over that the other day. So if you do have a question about that, like whenever you get the chance to do it, I'm probably gonna do this homework
Okay.
tonight, but you can
Alrighty. So we can
message
talk
me.
about it in the home. You could just text the group, I guess, about it when you do it. It was number 016, so you can write that down if you
All right, let
want.
me cool. All right. Anything else? I think this was really good.
Yeah, I
Like
liked it.
this.
I liked it.
All right, cool. But other than that, I think we're
All
gonna
right, girl.
cut it. All right.
Thank you. All
Bye.
right.
You're welcome.
Bye.